don't you think it is a playing with data or tampering the data in fact? Because the actual spirit of the data finishes.
No, the purpose of taking augmentation here is to terminate the autocorrelation. And the analysis which you can do some mathematics which is showing that if actually you are putting the augmentation on this side, the autocorrelation will finish. That is the purpose of this exercise. Yes. This is not tempering, although there are many other points which in which
In the model we take the actual data.
Yes.
But just we want to check this that it has a tendency whether or not to become specific.
Actually, if you are including one or two legs, you will automatically find that there is no autocorrelation left. If you want, I can do this exercise. Say, look, uh, here is estimate equation D of LGDP, and then we have C, and then we have LGDP and minus 1, right? Let me see the autocorrelation. I am applying the residual diagnostic and serial correlation LM test with two legs included. There is no autocorrelation basically. If I re-estimate, there is no autocorrelation in fact. There is no need of augmentation in this case. But suppose you are finding that there is significant autocorrelation and you are increasing augmentation, the autocorrelation will finish. But the question is, how many legs should I take? How many augmentations should I take? The solution to this question is like what we have learned last time, like what we have to do in the ARMA models. We have to take the minimum AIC and then the model corresponding to minimum AIC should prevail. But EVs will do it automatically. You don't need to worry about this. For example, I am having this series LGDP. I want to apply unit root test, and I have asked it to include Schwarz information criteria for the selection. I am giving maximum leg 5. What it will do, it will try 0 leg, then 1 leg, then 2 leg, then up to so on 5 legs. And for every leg it will calculate the Schwarz information criteria, and the point at which the Schwarz information criteria is minimum, it will report only that point. So I am doing this exercise. This has done the exercise and the selected leg length is 0. It should be so because when we have ran regression manually, we saw that there is no autocorrelation with 0 legs, so there is no need to go beyond this. So this is all about unit root testing, and there's one more thing. If you look at EViews, you have many options for the unit root testing. You have augmented Dickey-Fuller test, then you have Dickey-Fuller GLS test, then you have Phillips-Perron test, and then there is KPSS test, and then ERS and NG-Perron test. There is a large battery of tests. So which one should we use? This is very typical question. and there is no, you cannot find the answer to this in general in literature, but there is one paper written by me in which you can find some solution. This is basically my field of specialization. So one paper is there in which you can find which of these tests is superior, and that is Phillips-Perron test. The superior test among this list, I have made the programming of all these tests manually, and I have simulated large number of times, and after that I found that the best test among these is Phillips-Perron test.
Is it true that for small sample we should use NG parent?
No, it's not true.
But somewhere in papers I have studied.
On what basis?
That was not
That
a
matters.
Augmentation. Yes. That was not a
This thing matters very large. On what basis you are saying that NG-Perron? NG-Perron is basically latest among these. So someone would prefer the NG-Perron because it is latest. But actually what happens, the tests are to be analyzed on the basis of size and power. And this is very typical job. Only few people can do this. And I have repeated all this exercise.
They have the high power.
Yes, this is having better power.
NG and Perron test is based on the asymptotic properties.
High power.
The size and power of this test is estimated on
Oh.
asymptotic sample size. So that is why there is no use of.
चलिए मैं आपको एक इंटरेस्टिंग बात बताऊँ NG-Perron के बारे में.
अच्छा सर एक
Let me-
एक छोटी सी चीज क्लियर करते जाए, एक्सेल पे जब हम लेंगे तो लैग टर्म का डिफरेंस जनरेट करके उसको इंक्लूड करेंगे ना उस सीरीज को
जी,
रिग्रेशन में.
यस.
लैग टर्म का डिफरेंस का लैग टर्म नहीं, कि डिफरेंस का लैग नहीं, लैग टर्म का डिफरेंस.
It is something same. If you first take leg, then take difference, and if you take difference, then take leg, these are the same things.
सेम चीज है,
Yes.
because it is multiplication
जी,
in fact
जी.
mathematical.
Okay, so let me illustrate you what NG-Perron test is doing. GENR. Yes.
Sir, please आपके पेपर का टाइटल बता दीजिए साइड में फिलिप्स पैरेंट टेस्ट में
इसका टाइटल है ए टेस्ट ऑफ यूनिट रूट टेस्ट. हाँ, यस. पूरा टाइटल मुझे याद नहीं है, लेकिन ये फ्रेज इसमें है. What we have done, we have generated a series X, which is just random numbers. Let me apply NG-Perron test. What this test is saying, this time this has rejected, but most of the time this does not reject. Even with you have stationary nahi, balki you have white noise series, and it is quite frequent that you are repeating you are testing the white noise series, but NG-Perron test fails to reject. Anyway,
इसका नला रिवर्स नहीं था.
नहीं, इसका रिवर्स नहीं है. The KPSS test is having stationarity as null hypothesis, not the NG-Perron test. So, anyhow, you can apply any unit root test from this menu. You have a battery of tests including NG-Perron and Phillips-Perron and so and so. and according to my analysis, the best test among these is the Phillips-Perron test. Now, there is one more question. Should we apply two tests or not? What if we apply the Dickey flow test as well as the Phillips-Perron test? Then what will happen?
Sometimes result differ कर जाते हैं, almost 99% same आते हैं.
Should we report two tests or not?
Yes, sir.
This is a typical question, and my reply to this question is we should not do multiple testing. Why? See, every test is having some probability of type 1 and type 2 error. And if you are applying two tests, the cumulative probability of these errors will enlarge. It will become double. If you are applying two tests, then probability of type 1 error for one test is 5%, for the other test is 5%. If you apply all two tests, it will become 9%. Not exactly 10, it will become 9%. Right? And if you apply three tests, it will again increase to 13%, and so on. So